Hey there, this is Seth Waters from Channel 9 coming to you from NDC Oslo in the beautiful country of Norway. We're in the city of Oslo for this wonderful conference. I always have a good time with the folks at NDC. I've never been to the one in Oslo though.
Oh, really?
First time. I have some real special guests. Why don't you introduce yourself? Tell us who you are.
Hi, my name is Dahan. I'm the CEO and founder of InServiceBus.
Hey, hi, I'm Daniel Marbach. I'm from Switzerland. I work for Particular Software, and Udi is my boss.
Oh, fantastic. So don't screw up.
Yeah, I'm
Just
really under pressure here.
No pressure here. There's dozens of people watching right now. By the way, if you do have any questions, make sure to submit them. We'll make sure to take them as soon as we can. So why don't you tell us a little bit about what it is that Particular Software does?
So we do a bunch of stuff. The bottom line is we build tools to make developers enable better .NET systems, complex business systems, the kind of stuff that you read about on all of the big websites and the really complex logic. We don't really get involved in small-scale little apps that are built for just a small team. It's the big complex stuff is what we do, and we solve the reliability problems, the high availability, the scalability, making sure that the code remains maintainable over time, and we provide the infrastructure that makes tens of thousands of developers able to do that without our help. That's the main idea.
So what is the difference between, like, I'm writing a cheesy app, a little cheesy app, and I've written lots of those because I make demoware, folks, that's what I do. When you go to something that's much larger and that needs to be much more reliable, what changes?
Oh, I guess the question is what doesn't change.
Right.
Because, it usually starts off with, somebody wrote a small app 10 years ago and then, business started booming and then they got 2 other developers to add features to it and now they got 10 times as many users on it. They're adding more functionality and all the time the code base grows and gets more complex. Eventually you kind of hit a point where the single database is starting to crumble and the UI is not responsive. At that point in time, that's when you need a different style of architecture to, for example, do things more asynchronously. Now, ever since Microsoft introduced async await, people are like, hey, this is going to be easy. I just async this and then I await that. Problem with all of that is what happens if there's a crash in the middle of that async? All of a sudden, all of your state just sort of fizzles out and disappears. So we come in there with durable queues and transaction management and threading and all of that kind of infrastructure, pointing developers into how to structure their business logic, including publish, subscribe, and event-driven architecture.
Sure.
From there, system gets more reliable. You can have more developers working in parallel without stepping on each other's toes.
Now, my sense is that from what I'm hearing, do I have to rewrite everything? Or is it like you can chunk this up and solve it a step at a time?
Right, so that's exactly what we recommend most of our clients do. There's always that sense of developers want to rewrite everything. It's kind of that this time we're going to do it right. But the nice thing about our approach is we can say, you can actually get into your existing database with a Sprock and then surface events from there. So you don't actually have to touch anything. You can just start emitting events from your existing code base and then start expanding other logic around the edges and then gradually, bit by bit, rewrite the parts that are emitting that data via Sprock into a better way of doing things.
Now, with the advent of the cloud and now these clouds infrastructure, moving over, is it the same kind of challenge that you're going to have? How do you do it in an agnostic way, for example, that you want to have stuff on-prem, stuff on the cloud? Is it the same kind of process?
Well, I'm not sure I'd say it's the same kind of process because so much of the storage ends up being different. There's also challenges between having Azure Service Bus and Azure Storage Queues, and their APIs are slightly different from each other. And if you want to be on AWS, then they have SQS and SNS. So each cloud provider has something that's slightly different in terms of API. Most developers are trying to hedge their bets and create some kind of infrastructure layer on top of that, so that if they need to move from one cloud to another, or they need to take something from cloud to on-prem and back again, they try to create some kind of abstraction layer.
Sure.
And it turns out it's actually a lot harder to do that than you might think.
And it might not be a question of even hedging your bet. You might have a customer that uses AWS infrastructure, and you're an Azure person, and you still need to communicate in a way that's agnostic. Is that correct?
Right. So Where we're coming in is to provide that higher level API for developers to write their business logic, to write all of their pub sub code and their long running processes. And then we do that adaptation to SQS, SNS, Azure Service Bus, Azure Storage Queues, and as well, if you wanted to have everything run on-premise, RabbitMQ, MSMQ, just regular SQL tables like we talked about before.
So is the big architecture change more of one that you're changing to sort of a messaging protocol? Is that the main crux of it?
Right, so I'd say that a big part of it is indeed making things more message-driven, more asynchronous. But at the same time, it's not just about making things message-driven from a programming perspective. You got to have the underlying transaction management.
I see.
So without that, you can end up in cases where messages get lost, your database ends up in an inconsistent state. So we make sure all that is handled.
Okay, so this sounds really good, but Daniel here is going to show us what this actually looks like in practice with a little bit of a story involved, right?
Right.
Yes, exactly.
Take it away, Daniel.
Okay, so, well, I'm from Switzerland, like I said, and Switzerland is pretty well known for its delicious chocolate.
Of course.
I know Belgian people would say differently, but I think the Swiss chocolate is the best chocolate. And I actually brought you some.
Oh, wow.
It's dark chocolate.
Look at this.
From Switzerland.
Dark chocolate, that's actually my nickname.
Product placement here,
Yeah.
live on Channel 9. So, well, in this hypothetical situation, there is a Swiss chocolate manufacturing team, and they have an existing legacy application on premise, and actually they want to make it scalable because they realized, especially around Easter, they lost a lot of orders, and of course
that's horrible.
That's horrible, right? If you want to ship the chocolate worldwide and you can't deliver, that's horrible for every company.
Of course.
So they thought about how could they actually scale the chocolate or the chocolate order management system, and someone from the team stumbled over this Microsoft technology called Service Fabric. Mm-hmm. Awesome. I think you have talked about it as well on Channel 9, right? And they decided they want to go for Service Fabric because it allows them to do some kind of a lift and shift kind of architecture where they start on premise and gradually move their microservices to the cloud. But in order to be hyperscale, they actually realized it's not enough to just do like the scaling by cloning things, like having multiple instances combined with microservices. They also realized that they need to do data partitioning. And now we're circling back to NService Bus because, like Udi said, NService Bus is built on top of queues, right? So you have a queue like an order queue where your orders arrive, but how does that affect when you do data partitioning? So, of course, the partitioning itself also needs to apply it to the queues.
And this is even more important when you're looking at the perspective of microservice architecture, because data, it's literally, you have to pass around data. It's not a question of, hey, let's just all call the same database, because that's not even how it works anymore.
Yes, especially with Service Fabric, where you essentially with stateful services, you move the state closer to the compute layer. What's going to happen is you will have multiple partitions, and what it means is you have to route basically the requests to these partitions, and the same also applies for messaging.
I see.
So the team realized this challenge, and they came up with this architecture here. So they have like an order microservice with with a stateless front end, and the stateless front end sends in chocolate order commands. Depending on the chocolate type, let's assume they partition by dark chocolate, brown chocolate, white chocolate. So they have the stateful backend service. It fetches messages from the queue, right? And then the whole business process is triggered. So in this example, we say, okay, if someone orders a chocolate, let's say the dark chocolate type, we also have a buyer's remorse, because you never know, right? Sometimes customers want to cancel their orders, and that's handled with what we call a process manager, or in NService Bus terms, it's called a saga, a chocolate ordering saga. And this saga then manages the whole process of doing payment gateway calls, and then at some point when the order needs to be shipped, it then basically sends a command to the shipping, and the shipping then publishes events back to that saga.
And that's interesting, right? Because even in the case, let's just say your whole website explodes, the durable messaging, those orders will all be there, and when everything turns back on, it'll start peeling. And I like the idea of commands as nouns, right? Because now that you're sending commands to the broker as nouns, even those things that it's supposed to do remain stateful in the event of a catastrophic failure.
Mm-hmm. Correct. Yeah, and here I've outlined it here. So what's happened is because the chocolate order front end composite UI part knows the destination, which is the order receiving backend. So what it happens is it will do sender side distribution. So basically it knows the partitioning function, how to translate the orders into a given queue based on the chocolate type. And here, when we publish, for example, a chocolate order received event, this is then published to the shipping service, and the shipping service itself has its own partitioning schema, right? This side cannot inflict any kind of partitioning to the shipping microservice because this is a completely dedicated bounded context and domain, which then sometimes, if with data partitioning, what can happen is that an event arrives on the wrong partition and it needs to be redistributed internally in order to end up on the right partition. That's what we call smart routing, or here in that case, receiver side distribution.
So there's a lot of vocabulary here.
Yeah, I know.
So we heard about partitioning, we heard about message queues, and we heard about routing. Can you put this into context? Are these programming structures that we're using?
Well, let's see how simple it can be in terms of code. It sounds really complex with all of these pieces.
I'm a little nervous here.
Okay,
Yeah.
so let's see briefly. Okay, so we have here this logic. So we have the front end. It's a classical ASP.NET Core application with a controller, which allows to send in chocolates. And as we can see from nService Bus perspective, this is super simple. We just send in an order chocolate command, and that's it. That's everything we have to do.
Nice.
And on the receiving side, we have the order management system, which then just declares
And
a
is
process.
that just like an API service or something?
It's even better.
Oh, okay.
It's a message-driven API.
Oh, I see. So it pulls messages off queues and does what
Exactly.
Okay.
So what we then see here is this is the order process manager. So whenever this thing comes in, I just declare basically I want to handle this order chocolate command. I implement this handle method, which is async, and then I say, okay, buyer's remorse, wake me up in 1 second. So after 1 second, the buyer's remorse is over, and then the timeout is triggered, and then the process continues.
So let me go through this code because this is super interesting to me. First of all, your interface names are super nice. I think you went way too fast. So scroll up a little bit. Like the names, like I am started by message, like that's super nice.
Yes.
First of all, because they're like I've seen some weird interface like I handle message async. It's like okay, that's not helpful. But this is saying I am started by a message order chocolate, and I handle messages that are payment response, order ship, and these are the ones that handle the timeouts.
Right.
Correct. And
So I like the naming. That's the first thing. The second thing I like is that when you receive a message, you also have logic that says, wait, right, for a certain amount of time, because your business logic might have that.
Exactly.
yes, exactly.
And so that's really nice. And then the third thing that I like that was really nice is that all of these interfaces are going to handle these events for you without having to do any other code.
Exactly, and it's automatically correlated based on the order ID, as you can see. So what it means is we have an order process manager per order ID, and all the events and messages, they're correlated automatically together on this order process manager per order ID.
And then the last thing I saw was that you have an annotation here that this is supposed to work on top of Service Fabric.
Yes, exactly. So we're using here the Service Fabric persistence for nService Bus, which then basically saves the state into reliable collections behind the scenes.
And I've had Mark Rasinovich on talking about reliable collections. Those things are literally fault tolerant. They will not break. They have quorum members.
Yes, they're
voting,
replicated,
leader
transactional.
election. And so this automatically says, just use that.
Yeah, exactly.
This is really
That's all you have to do. And the rest, here in this example, the whole partition of fine routing is all done behind the scenes by nService Bus. And we can actually have a look here. I have it deployed here on my local cluster. It's using Azure Service Bus. And this is the application.
Okay.
Awesome UI, as you can see.
Yeah.
So if we want to order a dark chocolate, we just hit this button. And what we can see then here behind the scenes is when we go to the diagnostics event view, we can then see behind the scenes an order is started, so the order chocolate event is received. Should I zoom in?
Yeah, let's do that.
Okay. As we can see here, the order chocolate is received. It's a dark chocolate type. It's processed on a process manager for that given chocolate type, and then it sends out a buyer's remorse timeout. And as you can see here, everything is internally correlated and all done behind the scenes, so that it makes sure that you end up every time on the right partition where the state for this order is currently managed, based on the chocolate
explain
type.
to me this partition part, because this is the part that's maybe a little confusing to me.
Okay.
What do you mean by it ends up in the right partition? Is the routing happening with the messages to be in the right spot? Explain that to me.
Yes, exactly. So let me briefly go back here. So what we can see here is when we enter a new chocolate order of type dark chocolate, it then this part here knows that the chocolate type is the destination is the dark chocolate queue and the dark chocolate partition. So with Service Fabric stateful services, we have per partition type basically an endpoint or a service instance running inside the cluster.
I just want to add that all of the things that Daniel is saying, it's not code that you have to write.
Right,
yes.
It's not. I'm looking at that. I just, I feel like if I don't understand, I'm going to write some code that's like, where did this even go? And so that's the part that, now that I understand where it's going and that it understands it, that's really cool.
Yeah,
Right.
and for example, what you can do as well is, if you go back, and that's where the beauty of N-Service Bus really starts to shine. For example, when you're losing connection to the cloud is currently down for a period of time. And in this example, the team still had a RabbitMQ cluster running. What we can do with N-Service Bus is, currently we're using Azure Service Bus Transport, as you can see here. That's the only thing you have to write, Azure Service Bus Transport and the connection string, and that's it.
Right.
And then it works. And now, if we want to switch over, for example, to RabbitMQ, then it's just a matter of basically going for nservicebus.rabbitmq, fetch the right NuGet package, and then install it where it's needed, and then pull down this NuGet package, accept the license.
And so you are hot swapping out
Correct.
the actual message persistence mechanism.
Yes, and now I just type here RabbitMQ transport. This is something that is specific to Azure Service Bus Transport, so I have to disable time on ledger. We're not going to talk about this here. And here I have another one. I just do then RabbitMQ transport. I also have to do here delayed delivery. That's something that is required for Rabbit for our transport. And then, of course, I need to somehow tell the application where the broker lives. And in order to do that, I need to basically override the connection string. And
so what you're doing is you're effectively swapping out Azure Service Fabric for RabbitMQ, which I know is not a trivial thing, right? Because it's completely different. RabbitMQ
Correct.
is a local, like, message queue thing that works on top of MSMQ. Is that right? Still?
No,
Yes.
RabbitMQ is separate from
separate.
MSMQ.
Yeah,
Okay.
oh, sorry.
Separate
sorry.
technology.
So now I just have to say here, and this is the specific connection string. I say localhost, right? If I can type localhost, I save it. I have to compile it, and now I'm doing something that I deploy with Visual Studio, right? I should be in production. I would probably deploying not with Visual Studio, but with like something like PowerShell. So I publish this application to the local cluster. I publish it, and this is going to take some time. So
as it's going through and doing this, you can show the boundaries of my understanding. MSMQ is the Microsoft message queue that works on the local. RabbitMQ is an open source one that does a similar thing.
Right.
But you're effectively switching from something that's happening in Azure Service Fabric,
Right.
has their own storage mechanisms, to something that's working in a local cluster. Mm-hmm. Okay.
And did you see how fast that was?
Yeah, that was not, and I literally was trying to speak over it for a little bit, and then it finished before I could finish.
yeah, well, we have to wait. I think probably the longest part here is the deployment to my local cluster. It's going to take some time. As soon as it's done,
But as it's doing that, you didn't have to really change any other code.
just the
know?
connection string.
Did you notice no change to the order process management?
Right. Yes.
No change to the client that's actually sending the messages.
Sure.
No change to the definition of the messages, right?
Yeah, I mean,
So let me.
It's very different things too. So I mean, that's the thing that's really cool.
So as we can see now, we should see here connections on the RabbitMQ broker. As you see, multiple connections from different partitions. We should see now here NService Bus created all the queues necessary and all the bindings and everything that is necessary to run it. And now we can just order dark chocolate again. And as we can see behind the scenes in the diagnostics window, it's still processing. Let's clear it so that you actually believe it. Let's do brown chocolate, as you can see. And let me show you that it's actually also working here with RabbitMQ. We see here we have an audit queue. And let's fetch and see if there are actually messages in there. Let's get the last 10 messages from the RabbitMQ broker. And as we can see here, we have the full history of the ordered chocolates, the buyer's remorse period, and everything that is now running inside Service Fabric, partitioned, now with RabbitMQ.
That's actually really cool. So was the RabbitMQ something that was working directly in Azure already? Did you have a RabbitMQ message queue that was up there in the cloud for you?
Currently, I have it on my local machine. So previously, I connected from the cluster on my local machine up to the cloud to Azure Service Bus. Now I'm connecting from my local cluster to my local RabbitMQ broker.
I see.
And now
But this
everything
could also work on the cloud.
Sure.
There is RabbitMQ available in its own cloud environment. So again, if you're saying, hey, Azure Service Bus goes down, I want a hot swap to a different RabbitMQ in the cloud. What was the name of that RabbitMQ provider that's available online? It's not IronMQ. There's another.
I don't remember.
There's probably something. I mean,
Yeah,
there's tons of queuing systems.
there's a bunch of queuing systems online, and they all speak the same RabbitMQ protocol. So you can actually point to a different cloud queuing provider that supports RabbitMQ, and you're doing that hot swap live. It actually, when you think about it, it would have taken longer to have a meeting to decide which queuing environment we want to switch to, rather than actually doing the switch.
Yeah. And here's the other thing that I've realized, because there's different kinds of queuing that happens in Azure. Because there's Azure, there's in the storage area, there's message queues there.
Right.
But then on Service Fabric, there's different persistence mechanisms. So you might thinking, I want to go to Azure Service Fabric. If you're using this technology, you can swap over pretty easily.
Right.
That makes sense. Okay.
Yeah.
Yeah. Okay.
All right. So that was really nice. Is this code available somewhere?
Yes, it is available. So you can find it here on this link. Let me briefly show it to you. It's a content for my talk on Friday.
Okay. This is pretty cool. So let's get into, because we have about 7 minutes left. Where can people go to learn about this stuff and figure out this stuff?
You want to
Right.
show?
So I'd say the first thing to do is just take the introduction to NService Bus. The link's right there on the slide, and really you just Google for NService Bus and you'll find this stuff. Sorry, you Bing for the NService Bus.
You Google with Bing, right?
Exactly, exactly. And then from there, it'll really take you by the hand, and in 15 minutes or less, you can have a bunch of endpoints, pub subbing, running on top of RabbitMQ, MSMQ, Azure Storage Queues. It really is very straightforward to get started. And at that point in time, when people have the technology working, then the really interesting discussions start about, well, how do we turn our business process into be like a more event-driven one? How do we migrate our legacy code? But most of the underlying technology, all of the underlying pipes and that kind of stuff, we got you covered.
So I remember that, because I followed this for many years. This has been around for a long time.
Yep.
And I went through the tutorial and played with it. It was really nice. It was open source back then. Is it still open source today?
Right. So in terms of open source, yes, all of the source code is available on GitHub. But in terms of the actual use of it, we've found out that companies really want, when they're basing their Easter time mission critical chocolate management processes on there, they want to know that something goes wrong, they uncover a bug, that somebody's going to be on the phone and fixing it for them in real time.
Sure.
So there are commercial licenses for all this kind of stuff. And the reality is, for most development environments, it's so much cheaper than actually having a developer struggle with this stuff themselves. So we'd be happy to talk licensing if anybody really wants to get into that.
Look, between us, girls kind of thing, like if I don't know how a developer is like eating and sleeping with the code they write, I never can be sure it's going to be around long enough to support my business.
Right.
And so I don't mind at all people charging for good code. Yeah. So they can go here to find out how to use in-service bus. Is there any other information that you'd like to get out there?
Not from my side.
Well, I guess I'd say that the next step from learning in Service Bus is actually moving into thinking about service-oriented architecture, microservices, how you manage your data. And that's when we've got lots of videos available online. People can learn more about the design of large-scale, complex business systems on top of these types of message-driven patterns.
That's awesome. And now, especially in the microservices era, because I remember this has been out for many years.
Right.
And I remember that it was, when I heard it first, this is to make things more scalable, more friendly. But in an era of microservices, there really is no other way to do things, in my opinion. What do you say?
Well, I think that some vendors might take issue with the fact of saying N-Service Bus is the only way of doing microservices.
What I mean is that you have to use stateful messaging because you can't share a database anymore.
Right. So if you actually want to get the benefits of a microservice architecture, you really need to follow a lot of these kind of patterns.
Sure.
So, I mean, yeah, you can kind of struggle through it yourself by saying, oh yeah, I'll just code something myself on top of the Azure Service Bus API. There's really a lot of knobs and dials and infrastructure to write yourself. So you will want something, some layer that abstracts that away from you.
Sure.
But the patterns, absolutely, you need those.
Yeah, because you can't, like lifting and shifting into a containerized environment, you can do that, but then you'll quickly realize there's some limitations, and if you want scalability, you need to be able to partition things out. And I've always been a fan of the messaging system because it allows you to separate things out in a much richer way, I think.
Yeah.
All right, where can people go to find out more about you folks if they want to get a hold of you?
Well, you can Google with Bing and Service Bus. Particular.net is the website. My name's Dahan. I've got a blog available online. This is Daniel Marbach. He has his own blog as well, where he blogs about a lot of Azure Service Fabric internals and how to get all of the magic that we've been showing you today working.
Awesome.
So take a look at that.
Awesome. Well, this has been very helpful to me. I'm definitely going to look at this. I'm really excited about the Azure Service Fabric stuff that you put in. It's definitely something we should look at. Thanks so much for watching. We'll be right back with another guest right after this tiny break.